So we are ready. Hello, Senophia. How are you? Uh, Probably your mic is muted, I guess. Muted. You have muted yourself. Unmute yourself, please. Hello.
Can you hear me now?
Yeah, I can.
Can you hear me now?
Yes, loud and clear.
Yeah.
Oh,
Doing good. Doing good, Chan. How are you?
it's fine. Yeah, it's raining actually. Outside, it's raining hard.
Okay.
Uh,
Uh-huh.
Weather is a little colder now. Uh, Now,
Okay.
I want to go back to the segment where we just got cut off. Okay, you were,
Okay. Okay. Yep.
but before starting that, please introduce yourself a little bit. Introduction portion. Last day, the that portion was a little bit noisy. It got recorded a little bit noisy. So what you do first,
Okay.
introduce yourself, then you are going to speak about your findings. Okay. At your
So
own.
you want to introduce myself and then
No. You self-introduce yourself. Okay.
I didn't get your Chan. Yeah. You want me to introduce myself, right?
Yes.
Okay. Then you want me to tell about my findings.
Yes.
Okay, fine. Okay. So shall we?
Yes. Please go ahead.
Yeah. So yeah, I'm Senophia Mary. Like I completed my PhD in 2019 and I'm from Tamil Nadu. I have done my project on electronic waste recycling and some kind of waste management activities in my PhD as well as my master's. So my master's is on environmental engineering. I'm basically a biotechnology background, so I love to work more on microorganisms and stuff. And so I just wanted to link my biotechnology as well as environmental engineering. So then I got this idea of bioleaching, and thanks to my professors for that, and they helped me a lot. And then I worked on a lab scale. Uh, I have designed a lab scale reactor for extraction of metals from the printed circuit board of electronic waste.
Wow.
And then I have published nearly some, say, 15 to 15 papers and some book chapters also. I've got so many excellent paper award, best paper award, poster award, presentation award, and all. And I'm like I have presented my papers in ISHWAL, International Society for Waste Management,
Yes, we know.
and yeah, so I have some thirst to work on the environmental basis. So I really concentrate too many problems at a time. Like I have worked on sanitary napkins as well, and you see, like I worked on recycling of fibers, like thermoset polymers, converting that into a fiber. I worked on that, and it was published in a very good impact factor journal. And yeah, so these are mine. So I really had a very wonderful lab in Government College of Technology, Coimbatore. It was a very good laboratory for environmental engineering. We have a section for nanoscience and technology, and we have a number of equipments over there. So most of them, like most of the characterization part and all, we don't have to go outside. Like we have enormous to do inside the college itself, and it's for free of cost for us as scholars. And I've guided nearly some, say, 6 master students, and helped some PhD scholars also, helping some PhD scholars also.
Actually, you
And
are helping me to writing for writing my paper. Actually, your interview is going right into my paper. So you are helping me in a larger scale. in a long distance way.
Okay.
You can say that.
Okay. Okay. I really wanted to publish too many papers. I love writing journals, writing papers to journal, like writing papers and publishing it in journals. So I'll write and the counterpart will be done by my colleague. So we do a kind of collaborative work, and I actually we have a team of e-waste workers together. So we'll do that, and it's really fun. So I'm inspired by many of my friends. So one such is my friend. He's very close to me. So he has written nearly 16 papers in his PhD itself. So he's such an inspiration for us to write papers like that. But he had such a good guide. So something like that. That's something like you need some patience, perseverance. That's what PhD is. And yeah, I've completed it in like 3.5 years. So it's just a continuation from my masters. So I don't have to go for a base search, and really it helped me a lot. So one of my a co-guide was uh, an environmental engineer initially to a central pollution control board, so like Tamil Nadu pollution control board. Then now she is a joint director, and so she helped me a lot, and like made me work on electronic waste like anything, and she helped me a lot. Like she will come with me to the site and work for us. So we have thankfully, thank God, we got so many good professors and engineers for us to help at the time. And my external, like the examiners were my favorite professors, Dr. Madhav Kumar sir and Dr. S.T. Ramesh sir. So they were my inspirations. Actually, they where so many they have so much in their mind. So they I got them as my external examiners, and for like Indian experts actually for my PhD viva. So they gave me a lot of uh, ideas even at my PhD viva. So even at the time I felt like, oh my god, we should have done this and that. I don't even feel like I'm satisfied with my PhD, so I just wanted to continue my research.
Mm,
So I'm waiting for a postdoc actually.
okay. So you are currently
Yeah.
doing postdoc.
I wanted to do a postdoc in a very good university. Yeah.
Okay, great. So
But now I work for a GIZ, like it's actually a GIZ project under Gopa Infra. So I'm a freelance consultant now. So I work for Gopa Infra, I work for IGS, Indian Green Services, and yeah, so we do a freelance consultant now.
okay. Uh, we'll talk about that institution. Probably John, Bishu gave me an email ID of that institution. Prasant, someone named Prasant. Uh,
Yeah, 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 yeah.
so we will. I will try to take an interview of him also. Okay. So we'll take
Okay, okay.
recycler's point of view in
Mm-hmm.
my paper. Okay. So we will do that definitely.
So actually, myself and Prasant have to together. Like we have a paper and it is there on internet. Like you could find them in Google Scholar. So it's like recyclers' perspective only. So you might have come across that paper, I guess. So like I wanted to write at the perspective of a recycler. So what are the problems they face? So maybe that could actually help you, I guess. So it's a direct conversation from Prashant actually.
Okay.
So yeah, so like we do have collaborations.
I
He
will
gave me some
definitely read
waste,
that
e-waste for my PhDs.
and
Sorry.
I will definitely read that paper by you and Prasant, and then I will go for the interview. So
Okay.
it will help me to form the questions and uh, to outline the uh, outcome in my paper. Okay. Uh,
Yeah, yeah, that will really help.
okay. Please tell us something about your work with the bioorganisms. Talking about last day. You are talking about you want to use bioorganisms to dismantle the electronic components from a PCB, that sort of thing.
Okay. See, actually, I used microorganisms to extract metals. See, when there is see, consider this is an electronic waste. So this outer part has a thermoset polymer. So within this, you have this printed circuit board, which is having the like the 30 percentage of metal of the entire system. So that metal should be leached out because we lack the renewable resources. We don't get it back actually. The non-renewable resources, or we are lagging all those things. So I wanted to take, like, consider this as a ore, and then we are extracting the metals. So that way we could actually convert this non-renewable into a renewable thing, because already we know that energy can either be created or be destroyed. So it is just transforming. So this is a transformation. Again, we could transform this into other another form. So that is the main idea. And there were a number of microorganisms which are like starting from 2002, I guess. 1998 or 99, Mr. Helmut Brandl, Dr. Helmut Brandl. So he is the one who initially started on bioleaching of electronic waste. So this is as far as what I have learned or what I have researched. So that guy, that professor is like, he is from the university where Albert Einstein studied, worked, and all.
Okay, okay.
So this professor actually initially worked on microorganisms to extract metals. So then I wanted to work on that, but the small alteration what I've done is those professors would actually pulverize in the sense they'll shred off or powder, convert the e-waste into powder, the PCB into powder, the printed circuit board, what I mean, which has a number of metals with it. They'll pulverize it, and then they'll like use microorganisms to extract metals. So which I feel like, or when I was presenting this to my professor once, so it suggested me, why do you over feed my microorganisms by adding too many plastics to it? So why can't you just like take out the plastics and give only the metal, so that it'll be easy for them to leach out. So then again I wanted to work on that. So then I found something. So when you pulverize it, there is a lot of like dust generation. You get too many dust particles. So the particulate matter will be less than 2.5, which is again going to be a problem for you.
Okay.
Then I really wanted not to pulverize them. I just wanted to use the entire plate for my research. So I just used some solution to remove the epoxy coating first, and then that was again presented as a paper, and then it was published in Sage Waste Management and Research. Then again, the second part, that is, like, I am just altering the pulverized portion with the like non-pulverized, the whole portion. So that I just used some string to like leach out the metals from the PCB. So I'm not pulverizing anything. I'm not converting the plate into powder. So that's what plated sample, powdered sample. I just did a study and then found that plated sample gave more result than powdered sample. So this is the initial part of my PhD. Then I wanted to design a big reactor so that this process actually will help to extract metals in an eco-friendly way. So that is why I wanted to take this. Then I found like one more person, like he was also a PhD scholar when I was doing. So his name is Nitin Adapure. So I was just referring, like, go through something. Then I found that this guy has also done the same thing. But the thing is, this guy has not used the initial epoxy coating leaching thing, like removing thing what I have done. So there was a little difference between our research in that way. And then the microorganisms what he used is different. What I used is different. And then he didn't go for a reactor design. So I did a reactor design. So this way we actually have to compare a lot of research works, what he has done, what I have done, and on which way I am in it. So all these things have to be noted, and then finally, I like with the help of my professors, I designed one reactor, and then it is also successful. So but still I wanted to, like that is my future scope. I wanted to modify the reactor, and if that is a successful one, I actually, like extract metals out of the printed circuit board without pulverization, without causing any air pollution, so that it could be, like you could extract metals. Because these days you could see in the literature, just because of pulverization, there is a lot of metal contamination in the air.
Yes.
So this metal contamination, when it was inhaled by students nearby, or any, like any workers who are there, so they result in a lot of like tissue damage, breathing illness, everything. Irritation is a basic thing, but there are lots and lots of other diseases: kidney damage, heart failure, brain failure, everything. So these things are there. So they, all these problems could be, like rectified by this method, like using the entire plate. So then after extraction, after completion of like extraction part, I wanted to take that metal from the pool. So I went for again activated carbon. That is the most, like very most common thing. So for that, I used again waste. So waste from fruits, because you could see, like in the biodegradable waste, in the municipal solid waste, you could see a lot of fruit waste, fruit peels over there. So in Tamil Nadu, you could, like in most of the parts of India, we have Mosambi juice, lemon juice, and then we eat banana. So these are the common things. So I just converted that into activated carbon and then used for extraction of metals from the metal pool. That's the extracted PCB metal pool. So after that, after extraction, then again you have that substance with you. So what can be done with that? So again there is a question mark. So what I've done is I mix it with another polymer. That's a thermoplastic. So then again I made a fiber. So that nanofiber membrane could be used as a used for filtering substances, used as a filtering substances.
Okay.
So I've just like uh, designed the membrane, but then I didn't go for that. That was just an application out of it, but that doesn't come into my PhD. So until the extraction part and the removal of metal from the pool, I completed my PhD. So then the next one, I've done it. I presented a paper. The paper is published, but then that is actually after my, it's kind of a postdoc portion.
Okay. Nice.
Also, I worked as an yeah.
Nice to know that. There's a little time limit. I don't know if it showed in your screen too. There will be soon. This meeting will be ended by the Cisco itself. They have a
Okay.
session near. So just wrap it up really quick. Okay. We got
Yeah.
1 minute actually.
Oh, just 1 minute. Okay, fine. So, what do you want me to tell now?
Uh, you covered most of the your PhD session. We think I think we can finish this up.
Wind up.
Yes,
Yeah.
wind it up. I will I will definitely call you about Prasant and how to contact him, and
Okay.
probably I am going to take an interview session with him also. Okay.
Okay.
Thank you very much for sharing your research with me and all the
Thank
insights.
you.
And definitely, when my paper, it's initially, I think it will be a book chapter. Uh, I don't
Okay.
know what will be the outcome. I will definitely share it with you. Okay.
Sure, sure. All the best. All the best, Chayan. You do a very good job. Thank you so much, and it actually boosts us also. Thank you.